Hello, everyone, and welcome. We are going to talk about some fun stuff, my favorite topic in information security, which is ethical hacking. Just real quick about me. I led the offensive security team at a large financial for 10 years. And I say I led because I recently resigned. Looking forward to my next gig, which I'll be announcing June 1st. During those 10 years, I tried to contribute back to the community and always giving back to a community that gives us so much. So I've worked on things like the common vulnerability scoring system, which we'll talk about today, obviously, since we're talking about ethical hacking vulnerabilities. I also wrote a framework with some of my colleagues in the Global Financial Markets Association on performing pen test, threat-led pen testing. I'm a SANS certified instructor. I have a course, a 2-day red team exercise and adversary emulation course. I recently got into National Security Institute as a technologist fellow to start talking to some of our lawmakers about cyber laws and trying to move the needle the right way. I'm a big fan of ISSA, the Information Systems Security Association. I'm a fellow there. I'm also on the board of the South Florida chapter, where I met my friends here at Digital Era. And I also wrote a book on an operating system you should not be running anymore because it's end of life, which was on Windows 7. This was on my past life. So hopefully everyone can hear me okay. I'm going to mute someone else here. There we go. All right. So what are we going to talk about? We're going to talk about ethical hacking. And what is ethical hacking? Well, really, it's a hacker, which in its traditional term means a skilled individual who uses technology and their knowledge to overcome a problem. The only thing with that is that around the 80s and 90s, hackers got a bad rap. They were doing things without permission and ending up in the media as hackers did this, or hackers broke into that, or hackers stole all this information, really making the word hacker something bad. So we slap the term ethical in front of it, and that is meant to mean someone that has permission. So an ethical hacker is someone that has permission to go in and use their technical knowledge to break into a computer network and evaluate security really with the intent of making it better and improving it. So you often hear the terms white hat and black hat. White hat are the ones that have permission, black hats are not. There's a whole lot more that goes on to be with what makes you actually ethical. It's not just permission. So lots of discussions there. I'm not going to touch on that here because I do want to get to just a whole bunch of demos and demo fails. There's a number of different references. I'll post them here on the chat in a second. So the first thing that most people start with is vulnerability scanning. Vulnerability scanning is an automated method of identifying vulnerabilities on assets that you're testing. So an organization says, look, I have all these internet IP addresses. Can you find vulnerabilities on them? Can you scan them? Or I have a web application. Can you scan this web application for vulnerabilities? And this is important. It's generally where everyone starts. It's the low-hanging fruit, if you will. And the goal there is to identify these known vulnerabilities. See, the way it works is a scanner that are made by a number of vendors, as you can see here, Nessus, Rapid7, Qualys, Alienball, IBM, HP, etc. They have these signatures. You give them IPs, they go and they communicate out with this IP address. They will do first ping scans to make sure the host is alive. They'll send SYNs and see if a port is open, right? That's a TCP scan. If per the RFC, if that port is open, it has to return back a SYN ACK, which is part of the three-way handshake that we need to do. So we find that if service is open, we then send it, or this tool then sends it a number of other packets to see what kind of response it gets. Based on the responses, it matches it with signatures, and then it can determine that there are certain vulnerabilities. So this is pretty hands-off. All you really need to do is purchase a tool. I'm going to show you Nessus right now, and it's not going to find O-days, right? It's not going to find anything that the vendors don't know about, what we call 0 days, which is a vulnerability that a vendor doesn't know about. And you can run these quite often. You can run them weekly, you can run them monthly, and the customer in this case is the system owners or the operations team, whoever actually owns um, that particular system. So I'm going to start here, and we're going to run some scans. This is VMware Workstation. I have a little more complex lab than most on their system. I have a PF Sense. This is a virtual firewall. It has 3 zones, one that gives me internet access, another one that's for the attackers, and then another one that's for the victims. And this is just so I have more visibility and really segment. So these systems are not on the internet. You can't connect to them. And that's kind of the way you want to do it. So we have 2 virtual machines that we're going to use as attackers. One is the SANS Slingshot Community Edition, and then the other one is the SANS Slingshot C2 Matrix Edition. We'll do that for the red team portion. So here, I just look at my IP address, and of course, I'm already mistyping stuff, so bear with me. Quick prayer to the demo gods. All right, so my IP is 10.0.0.1.1.8. I'm going to want to scan systems that are over here at this victim network. I can look here that this IP is 192.168.1.105, and then this other guy has 1.1.12. So if I didn't know that, I would start something with an Nmap. Nmap is a common tool that you use to identify hosts that are alive and also services that are running. So I can run a quick Nmap scan here against the entire 192.168.1.1 subnet. If that's a /24, there's a possibility of a total of 255 IPs. I'm going to run that, and it will come back and tell me that there are 3 hosts up. There is 192.168.1.1, which I can see there is the PF Sense. There's 192.168.1.105 and 192.168.1.12. So these are really the 2 that I'm going to scan right now. So what we're going to do is use Nessus. Nessus is probably the most known and most popular scanner, network scanner. So we'll use this one, but if you know how to use one, you know how to use any of the others, right? So I'm going to sign in. It's a web app. So the client is a web page or browser that connects here to my server. In this case, I'm running it on a local host. You can actually have these scanners in remote areas, such as inside your data center, inside your DMZ, or you can have them out on the internet based on what you're going to scan. You want to get as close as possible to these systems. So I'm going to create a new scan. We're just going to do a simple scan to discover live host and open ports. No, let's not do that. Let's do, what scan do we want to do? How about basic network scan? All right, we'll call this live demo for the gods. And we're going to give it our IPs, 192.168.1. Oh man, what were they? I didn't even take notes. 168.1. You should always take notes. Notes are good. 105 and 112. And then we go down here and we just launch it, right? This is just a very typical scan. I'm launching the scan right now before I show you policies and whatnot. If you want to take a look at policies, you go over to settings. This is basic. This is how it does discovery. So it sends ARP, TCP, ICMP, all to identify if these hosts are alive. Then it does port scanning to identify what services are listening. It does service discovery to see what service is actually running there. You can see here things like TLS. Then it does various different assessments. I just picked the default. You can also log in. So you can put credentials, and that is more of a white box scan. Right now we're doing a black box, which means we don't know anything about these IPs except for the fact that they're alive and we want to scan them. We're just learning about them. If we had credentials, we could actually go in here into Windows and put in a username and a password, and that way it'll log into the system and dump information out. So that scan is running. While that runs, I'm going to cover vulnerability assessment. And vulnerability assessment starts with that vulnerability scan, which you saw is a tool. That tool I'll show you shortly, the report. It's generally a long report, and it's just based on signatures and based on default ratings that you're getting from the tool. So the assessment portion is where you actually have someone that can think, generally a human, even though AI sounds very promising. Um, you have a human looking at these vulnerability results, and then they are going to verify some of these vulnerabilities actually exist. So the goal here is to identify all the vulnerabilities that an asset may have and report those. So you run a tool, it does all this basic stuff, right? It identifies what ports are alive, it identifies certain vulnerabilities, and then you have to go in and dig deeper, see if you find anything that you can verify and that might need a higher risk rating or a lower risk rating than the product that Nessus in this case is telling us. So focus here is still on technology and configurations. We want to identify any vulnerabilities on this technology. A common thing that we see on this is a new product. Before you put that shiny new product into your production operating system, you want to test it. You want to make sure that's not going to introduce risk into your environment. So you do a vulnerability assessment. You identify, you run a scanner, and then you go through and find issues. The focus sometimes is against particular policies and procedures. I'm sure most of your organizations have information security policies or standards. You want to make sure that what you're putting in there makes sense. So the frequency for this is generally one time per year if you're going after production environments that are out there and running all the time, or if you're certifying a product whenever you're certifying it. In this case, the customer are your system owners, your operations teams, engineers, and applications. Even though I'm focusing on IPs, you can actually do all of this on applications. So let's go back over to our scan. We see that's still running, and it's going to take a little while. So, of course, I came prepared, and I actually already ran this scan. So we can see here that we scanned two hosts, 192.168.1.112 and 192.168.1.105. Now, I can, if this was just a vulnerability, if this was just a vulnerability scan, I can just export this report and say, here's your report. This is what you need to fix. And you can look at details here, see findings like SMB signing not required, rated as medium, which is debatable. It has a number of different plugins that it ran. And then here we see other findings. So that's if you do a vulnerability scan. Now, when you're doing a vulnerability assessment, you're going to want to dive deeper. So I want to dive deeper into this host, 192.168.1.112. I see that there's two medium risk findings. Now, generally, you want to go through each of these in a vulnerability assessment and validate that that is actually a finding. You can validate it by connecting to that particular service with a tool that works for that particular service. So if you found like FTP, for instance, you can validate that by connecting to the FTP server. If you found Telnet, you can validate that server by connecting to it. And here I see that something's running, and it's a medium risk issue. It was published a while ago, and it's IceCast XSL parser multiple vulnerabilities. So a remote host is running a version of IceCast that suffers from two flaws in its XSL parser. So I look at the locally exploitable buffer overflow vulnerability. So local exploitable, that means I have to be on that system, which right now I'm not. And an information disclosure vulnerability. But this is interesting. What is this? What is port? It runs on port 8000. And it's called IceCast. So maybe I want to look in a little deeper into that. And of course, you use things like Google, right? And find IceCast vulnerabilities. See what vulnerabilities are out there. You can find CVE details and whatnot, and see and dive deeper and see if maybe Nessus didn't find a particular vulnerability and you're verifying that it's actually running. Now, I still don't have access to this host. All I know is that it's running IceCast because the port 8000 is open. We would want to do more work there. And then you do this for each and every finding there is. Yes, it's manual, but that's the whole point of having a human do this. Look, there's another issue here, like server message block version 1 enabled. That's an informational vulnerability? Really? SMB version 1? I'm pretty sure Microsoft told us SMB version 1 should be disabled. Yep, look at that. TechNet community article on Microsoft.com from 2019. Actually, no, originally published 2016. Says here, Microsoft stop using SMB1. Stop using SMB1. Stop using SMB1 in bold and interesting. SMB1 rings a bell. What did SMB1 affect? And of course, we can look up US CERT, Tech Alert, SMB1, and see that the US CERT back in 2017 also told us we should disable this. Look, in response to public reporting of a potential SMB vulnerability, US CERT, the US government, recommends that you disable SMB version 1. So I'm going to go on a limb here and say that this informational finding that Nessus is calling out is probably a little more risky than informational. And I'm going to go also on another limb and say that this IceCast finding that calls medium might actually be a little more important than it says. So that'll lead us to penetration testing. Penetration testing differentiates itself from vulnerability assessment in that you're actually exploiting vulnerabilities. A vulnerability assessment verifies the vulnerability is there. A penetration test exploits that vulnerability. And generally, when you exploit a vulnerability, you get access to that target system. So the definition of a pen test is to exploit the vulnerabilities identified and in a professional, safe manner, following the scope and rules of engagement, determine the business risk and potential impact. Now, the scope and rules of engagement is where pen testing got really watered down. If any of you work in PCI, the payment card industry, for instance, they have a regulation that means that dictates that you have to have a pen test done once a year, and that the scope is the payment card environment. Everything else is out of scope. So you can't like go and get access to one system and then pivot into this other one because that one first system was not originally in scope. So pen test is very scoped out. But really the difference is you need to find these exploitive vulnerabilities. And now the effort is less on tools and more on manual testing, more on like actual knowledge of this, right? Like how did I know SMB version 1 was an issue? Well, because I've been doing this for a while. Or I use Google extensively. I obviously use Google in ways that I knew exactly what I was looking for, so it pops up. But that is what you would have to do. You have a new product, you're looking at that product, you hear or see a new port that's open, a new service, you need to understand that service. How does that service work? What's it used for? Does it even need to be enabled? What kind of configurations are there? Can they be exploited? And then the frequency here is again once per year because it's manual, right? You need actual people thinking and looking through this. And one of the other differentiators is this is technology and preventive controls. You are finding things on technology. I'm not testing anything else other than this particular technology. So let's go and try to exploit this. So we see that this thing is running. It's running on port 8000. So we're going to start Metasploit because Metasploit is awesome. Metasploit is a pen test framework. It's an exploitation framework. It allows you to find vulnerabilities. It allows you to fuzz for vulnerabilities. And it allows you to exploit vulnerabilities. It also includes payloads. So if you find a vulnerability and you have an exploit for it, you send the exploit's going to take advantage of that vulnerability. But then you need a payload to actually do something after you exploit it. So just because I didn't plan this, we need to search for IceCast. There is an exploit for IceCast. I see it there. So let's use exploit Windows HTTP IceCast. There we go. Then info. So I know a little bit more about this exploit. I'm not going to just download something from the internet and run it, right? So here we see this is an exploit. It was disclosed in 2004. Shouts out to these people. And we need to set the R host. The R port is 8000. And then here we go. This module exploits a buffer overflow in the header parsing of IceCast version 201 and earlier. So we know it's a buffer overflow all we really need to do is set the R host, actually set the payload first, and we're going to use a Windows interpreter. Interpreter is the Metasploit interpreter. It is a payload that is awesome. I'll show you some of the things that can do, and then I'm going to do a reverse HTTP, and then show options. This will tell me what I need to set our host 192.168. What was that IP? 112, I think. It's a really good idea to take notes. Yeah, 112. Set L port. Actually, it's our set L host. What is my IP? 118. Copy and pasting for the win. All right. Show options. See if everything's there. Now, I am going to show you the other system just for fun. See, this is IceCast, and it's a media server. It waits for connections to listen. I just scanned it with Nessus. So look at all the various different connections it got. It doesn't have a client connected, but it did definitely get a whole bunch of different connections. And that was the Nessus scan that's running, which I'm actually going to go stop just so it doesn't affect. Okay, it's done. All right, so pray to the demo gods, and we do exploit, and yes, we got a shell back. So it went out, it connected to this service, it set an exploit. It successfully exploited this buffer overflow vulnerability. If I go over there, I don't see anything happening. Completely oblivious if I'm the user that I just got hacked. And then I get an interpreter shell. So this is an interpreter. We can do things like run help. Help is wonderful. Help tells us what we can execute in this particular system. And you can see that interpreter actually can do quite a bit. It's a pretty robust exploitation and post module that allows us to do many different things. For instance, if I run ipconfig, it's going to run the IP config on that system, right? And here it'll tell me the IP there. I can also just drop to a shell if you're more familiar with a command shell. So this is as if I'm just running command.exe there, or yeah, command.exe in this target system. You have to type Windows commands, and you see that I have full access to the system. I can see inside the temp directory. I can vim hello or actually I think it's edit hello.txt. I'll create a file. No. All right, but oh yeah, of course, because I'm on a command shell. So here you could do other things like get UID, see who I'm running as. I'm running as student. I could try to escalate privileges, etc. The point is, I am on this system now. I have exploited this vulnerability, and that is the very basics of pen testing. So when you run this, you're going to have a whole bunch of vulnerabilities, and I mean a lot. So I worked at an organization that had over 1 million hosts, and these two Windows systems that I just ran are pretty clean. They're brand new Windows 10s. They are fully patched. I literally just patched them yesterday before trying the demos. So you didn't find that many vulnerabilities. Now, if you've been running your systems since the NT days and just upgrading and migrating, which I know you all have, you are going to have a ton of vulnerabilities to go through. And prioritization is going to be important, because if everything's a priority, then nothing's a priority. So there's many different ways of going about this. One is to use the common vulnerability scoring system. Now, when a CVE gets created, it is registered in MITRE.org. CVE is Common Vulnerabilities and Exposures. So you can look up a vulnerability here. For instance, I just looked up CVE-2020-0796, also known as SMBGhost or CoronaBlue. And this is an SMB vulnerability. There's information about it. A remote code execution exists in the way that server message block 3.11 handles, I believe it was compression, right? So If we go to National Vulnerability Database, which I've already clicked here, we get a CVSS score. And CVSS is the Common Vulnerability and Scoring System. Version 3.1 is the latest version. So you can see here the score of 3.x, and the base score of that is a 10. It's a critical. That means if you have this vulnerability, you need to get off this webinar and go patch this right now. Because SMB is a service that listens on the network, it runs a system privileges, and it's just a really bad vulnerability to have. So this is one method, use CVSS, but there's a ton of vulnerabilities that have a base score of 10 or over 9. We know that. I'm part of the working group. We are aware of it. We're going to try to figure out other ways to do it. So what are other methods? One of the things we're talking about is an exploit predictability scoring system, where we can use historical data and information, threat intelligence, to say, look, this vulnerability will most likely be exploited. You need to prioritize. That working group just started. We had our first meeting last week, so it's new. There was an original paper published for Black Hat of 2019. You can read more. There's also Attacker KB. Attacker KB is also new. It launched last week, and I've been beta testing. I've been one of the users for a bit. And here you can look up CVE-2020 SMBGhost, and you can read the analysis. So in this case, I did this analysis. People can upvote or downvote the analysis based on what information you put. So the attacker value for SMBGhost is actually very high, and the exploitability is very low. It's common in enterprises. The default configuration of any Windows system has SMB running, therefore it's vulnerable. It gives privileged access because it runs a system. You can exploit this unauthenticated, and when I wrote this, it was difficult to weaponize. So you can read this. I'm not going to stay here and read, but you can go through and use this new site called Attacker KB to help prioritize what is of an attacker's high value. Now, if you're an ethical hacker, this site is also useful for you to find what vulnerabilities are likely that you can exploit in a particular environment. There's others, and I need to speed up because, as usual, I'm going way too slow. Tenable vulnerability report priority rating. This is if you use the Tenable Nessus product. It has a vulnerability priority rating. Rapid7 has a real risk score. If you use Rapid7's Nexpose, these try to prioritize and show which vulnerabilities you really need to patch first. And then lastly, Mandiant/FireEye also has a risk rating. I really like their threat intel. If you want more, there's an entire blog post on this, and I'll share all these links. But in ethical hacking, you can also evolve. You can evolve from a common vulnerability and exposure to a tactic, technique, and procedure. See, MITRE has CVE, which is for vulnerabilities. And vulnerabilities are always going to come out, right? Like every day, we have 100 more new vulnerabilities. So you kind of need to get that straight away, figured out first. If a new vulnerability comes out, you need to have a process, a vulnerability management process that gets it patched. Now, because new vulnerabilities are always going to come out, and we have tactics, techniques, and procedures that attackers use, then we are going to get into your system. So let me say that again. You will get hacked. Like, there is no more of, I may not get hacked because I patch super fast. No, you're going to get hacked. And that concept is called assumed breach. You will get breached. It could be by an exploited vulnerability, which you should have a patch management process, or it could be with a tactic, technique, or procedure from MITRE ATT&CK. Robert Mueller, March 1st, 2012 at RSA spoke and said, I am convinced that there are only two types of companies, those that have been hacked and those that will be. Therefore, everyone will be hacked. So what is our focus now? Our focus, once you got that vulnerability and threat management process squared away, right? It's process, it's people, it's not just technology. Then can you detect and respond to what comes after? And that's really where the red team comes in. A red team emulates these tactics, techniques, and procedures of real adversaries to improve people, process, and technology in the target environment. They don't just focus on technology as the pen tests and vulnerability assessments have. They focus on the people and the processes as well. As the Red Team Journal wrote in 1997, it's the practice of looking at a problem or situation from the perspective of an adversary. Our goal here is to make Blue Team better. We want to train and measure our Blue Team's detection and the response policies, procedures, and technologies, make sure they're effective. The only wrong way, as Ryan O'Hara says, to do Red Team is to not pay attention to your Blue Team. So this changes. It's now a more manual effort. There's some Red Team automation tools that are out there. It's a new market. We're looking into that. A lot of promising technology coming out so that you can automate some of these things. But the focus here is really on detective controls. We move from that mindset of we're not going to get hacked. We know we're going to get hacked. How can we detect it? How can we detect it quicker? And how can we test that our defenders, when they realize that we're getting attacked and one system has been exploited, how do they respond to ensure that all our other 100,000 systems are not? And the customer here is the Blue Team. So what's a Blue Team? The Blue Teams are the defenders. They are the ones in an organization that have to identify and remediate attacks. Some organizations have dedicated security operations center in their environments. Some use a managed security service provider. But it's also the hunt team, a team that's actively looking for an incident. The incident response team, the team that comes in and handles that incident and responds to it. And the team doing forensics. But I would even argue that the Blue Team is everyone in an organization. If you get a phishing email, it is your duty and your responsibility to report that. Because while you caught that it is a phishing email, someone else might actually click on it and get compromised. So the goal for Blue Team is to identify, report the attack, contain it, eradicate it. The effort, there are some automated tools, but it's a lot manual. There's a lot of people. You need people looking at these. And sure, there's SOAR vendors and these new EDR solutions, but you have to actually test that they work. So the focus here is identifying, containing, eradicating, and recovery from attacks. And the frequency is every day, 24/7. I worked at the SOC at Terramark for a year, and it was intense. Your customers, the entire organization. And then that's where Purple Team came along. So most of the time, Red Team works in a blind manner where we don't tell the Blue Team we're attacking. We only tell maybe the CISO or the head of the SOC. There's a White Team as well that kind of manages that relationship. And we go in, we do our thing, and then we come back with a report. Purple Team is working together from the start. So yes, red and blue makes purple. That's where we came up with this creative name. And it's not a real team. It's more of a function or a virtual team where you have your red team and your blue team working together from the start. So new TTP comes out, new exploit comes out. Hey, I heard about this through our threat intel. Let's work with our SOC folks. Let's see what defenses we can put between the gap that this vulnerability is out and we actually patch. We need some sort of detective control. Let's build that detective control. Let's work with our vendors. Let's test that control. And let's make sure that you're alerted to it so that we can improve it. So the red team emulates the adversary TTP. The blue team watches and understands it. They improve their detection and their response, their procedures and the technologies very efficiently. It's a more efficient way of doing this. Doesn't take away from the fact you still need to do some red team engagements, but it also has its efficiencies. And then we have adversary emulation, and this last demo is going to run right on time. Adversary emulation. This is where the red team emulates an adversary that has the capability, the opportunity, and the intent to target you. That means you need threat intelligence. What organizations are likely to attack you, right? Well, in January of this year, the US did an attack against an Iranian Soleimani and killed him. We believe that the Iranians were going to come back at us through cyber threat intelligence. So what do? Well, we learn how they work. We learn how APT33, APT35, etc., how they function. What do they do? What is their operations? What tactics, techniques, and procedures do they follow so that we can then emulate those exact same ones and see if our organization is prepared in the event that they actually attack. Frequency here is maybe twice a year or yearly. It takes a lot of prep to do a full end-to-end attack. looking at one of these. So let's go back over here. So MITRE ATT&CK, if you haven't seen MITRE ATT&CK, it's attack.mitre.org. It's broken up by tactics, which is the first row up here. These are the attacker goals. So the attacker goal is initial access. They want to execute something. They want to gain persistence. They want to steal credentials. They want to move laterally. They want to exfiltrate and impact your organization. Then there's MITRE ATT&CK Navigator. Here, you can select the TTPs that various well-known threat actors use. So I'm going to use APT33. I've been studying them for a while. This is actually the one you emulate in my 2-day red team class. They are an Iranian threat actor. So if I selected them, you can see here that they're highlighted. I'll change the color on that so that you can see it easier. So they do spear phishing with a link. They exploit for client execution. They run PowerShell. They do scheduled tasks that exploit for privilege escalation, right? This is what they are known to do. So what can I do to emulate that? Well, I'm going to do Empire because it's going to be the quickest thing that I can set up in this amount of time. If I look at Empire and I select it, I can see that Empire can do all of these various different attacks. So let's go and do that. I also have a site called the C2 Matrix, which allows you to download a different attacker. So I'm using this attacker. This is Slingshot C2 Matrix Edition. It is a virtual machine that has a lot of these command and control frameworks already installed. So we have Empire 3. We're going to start that with sudo empire, and we're going to emulate something in 3 minutes or less. So let's see if I don't mistype anything. Use listener HTTP info set. Oh, thank God. Is it all set? Please tell me that's my IP address. Am I at 1994? Yes, thank God. So everything's actually already set. I'm not going to go through and set this up. It isn't set. It isn't set. Set host HTTPS 10.0.0.194 on port 443 because I want connections coming over TLS. I want it to look like I am actually attacking here. What else do I need to set? I think I'm good. Let me see if I can just set port, right? So port 3, and of course I'm like running. There we go. So we have a listener. Is my stager already going to work? Probably not. Now I need to create a payload. I'm going to create a payload that is an HTA file. Windows/HTA. This is a type of file that will run on Windows. It's a HTML application. I run info, set the listener to HTTP, which is the listener I just set the out file to /temp/test.hta, execute. Good. Now I go on to another system. Make sure it's here. Is there a test? Yes, there is. I'm going to start a simple HTTP server on 8080. There we go. Now on this victim, I'm not going to spearfish because frankly, I just don't have the time. But I set up a web server. I would really be spearfishing them with a link, which is what this APT does. And it's called test.hta. If I get someone to actually execute this and click run, then on my system over here, I will get an agent connection back. There we go. So this agent is now running on my Windows system, Windows 10.0.0.1. It calls back every 5 seconds. So if you are looking in this machine, if you want to actually understand what is happening, you can run a tool like Wireshark. You can, when does anyone ever open Wireshark and not have an update? here I can filter IP address. What was the IP address? Actually, whatever, it doesn't matter. There I could see some of the traffic going back and forth, and it does it every 5 seconds. If we just sit here and chill, we'll see that happening, and I have access to the system. I can then interact with this host and run shell ipconfig, and in 5 seconds when it checks in, here it goes, it ran through. So, my gosh, that was very fast. The point of all this, because I did promise 10 minutes for Q&A, is to provide value. Any of these services, whether you're running a vulnerability scan or doing an adversary emulation, the whole point is to provide business value. Showing people a shell, sure, I showed all of you a shell, but you're all slightly technical, more technical than a executive. You saw that I have access to that system. But if you show an executive that, a shell doesn't mean anything. They're just going to be like, okay, whatever. I can't believe I spent this much amount of money on this. You need to show the business value. So understand the business requirements and communicate this in business terms. As mentioned earlier, Digital Era partnered with a new company I'm helping advise called Avance Cyber to provide any of these services. If you're interested, reach out. Information is down here on this slide. And then if you are interested in this, I'm only going to talk about adversary emulation and red team or purple team exercises at DerpCon, which is exactly a week from now, April 30th. It's a free conference. It's virtual. So I'll be talking more about this and not the first 40 minutes intro, just focusing more on adversary emulations and how to bring value through red team and purple team exercises. And with that, I'm going to turn it back over to Anne.